Okay, here we go. I am homesick with the flu, so we're going to do the lesson on a video here, and I just need you to take notes in your notebook, just like you would if we were in class together. I'll tell you some specific things that I need you to write down. But today's lesson is called 7.5 Negative Exponents with Powers of 10. You have two goals to write down, please. One is that I know what it means if 10 is raised to a negative power, and I can use the exponent rules with negative exponents. What's kind of nice about this lesson is yesterday I think it was Josh who had asked if exponents can be negative, so here's your lesson on that. If at any time in the video I'm going too fast, feel free to pause it. Remember that you can also rewind if something was unclear to try to hear it again. The sub will need to check your notebook after you finish the video in order to give you the worksheet. If you have any questions while you're working on the worksheet, you can shoot me an email. Obviously, by the way I sound, I'm not feeling the greatest, but I do have my email open today. So first we have our warm-up, and it's called Number Talk. What's that exponent? So you're asked to solve each equation mentally. You're welcome to write them down in your notebook, but remember that typically when we solve things mentally, we're just using our brain and not paper, pencil, or calculator. So the first one says 100 over 1 equals 10 to the what power? So we're trying to solve for x here. Let me get my pen. So 100 over 1 is just 100. And that would be the same as saying 10 to the second power, so x would equal 2. Next we have 100 over what would equal 10 to the first power? Well, it can't be 100 over 1, because in the last example we just said that that was 10 to the second. So somehow we need to divide 100 by something that will give us 10 to the first power, or just 10. So what do we divide 100 by to get 10? And that answer would be 10. 100 divided by 10 is 10. So x here equals 10. The third one is what over 100 will equal 10 to the 0 power? And yesterday we learned that anything to the 0 power is 1. We know that in order for a fraction to be equal to 1, the top has to equal the bottom. So in this case, x would be 100. 100 over 100 would be 1, which would be 10 to the 0 power. And the last one is 100 over 1,000 equals 10 to what power? So this is kind of where these negative exponents are going to come into play. But if you're looking at the pattern on the right side of these equations, we can see we go from 2, 1, 0, and if we're following that pattern, this x would be a negative 1. Another thing to look at is that so far we've just been dealing with numerators that are larger than denominators, and those are always giving us positive exponents. So is it possible that when the numerator is smaller than the denominator, that we then get a negative exponent? And what I do want to do is just kind of show you how to reduce this. So remember that when you have fractions with zeros, they can kind of cancel each other out. So this actually ends up being 1 over 10, or 1/10. And it is true, this is following a pattern of 2, 1, 0, and negative 1. So x here would equal negative 1. So the negative exponent table is our first activity, and you're asked to complete the table to explore what negative exponents mean. So go ahead and pause the video here because I do need you to get this copied in your notes, and I apologize today that I don't have this table, on paper to pass out to you, but if you could take a few minutes and just copy this down in your notes, and then once it's copied down, go ahead and press play again as I go through the table. So we're looking at negative exponents. We're trying to see where they come from and what happens. So we're asked to write things as powers of 10, then write what would those be as decimals, and then what would they be as fractions. So these first three right here, these are the three that we've been working with. These are the three we know really well. So 10 to the second power is 100. 10 to the first power is just 10. And you'll see in a minute while we're doing this decimal, this 0.0, you'll see that as the table goes across to the right. We know that 1,000 as a fraction is just 1,000 over 1. 10 is 10 over 1. And so now we want to take this pattern and continue. So 10 to the third, 10 to the second, 10 to the first, we would have 10 to the 0. We're just subtracting 1 from the exponents. After 10 to the 0, it will be 10 to the negative first, 10 to the negative second, and 10 to the negative third. In the next row, the second row, is writing things as decimals. You can kind of look for a pattern. So you can see 1,000 to 100. We've moved the decimal one time to the left. From 100 to 10, we've again moved the decimal one time to the left. Same thing from 10 to 1, moving the decimal one time to the left. So if we continue that pattern, if I move this decimal one time to the left, we would get 0.1. That pattern continues with 0.01. And then finally 0.001. As we're filling out the third row as fractions, so now we have 1,000, 100, 10, 1. We go to fill out the fraction row. You can you can look at how do we say this number. We say 1/10, so that would be 1 over 10. We say this number is 1/100th. 1 over 100, and then the last one is 1/1000th. And now we're going to go ahead and answer some questions about the table. Okay, so we've got the table filled out here still. First question says, as you move toward the left, each number is being multiplied by 10. So we're multiplying by 10 as we go to the left. And we've talked about that with exponents. Every time you add an exponent, you're just multiplying by another 10. So the question is, what happens as you move to the right? Now yesterday we discussed this as being we're dividing by 10, but they want to know a multiplier. So if we're dividing by 10, that's the same as multiplying by what? Well, remember that dividing by a number is the same as multiplying by the reciprocal. So if we take the reciprocal of 10, the multiplier here is we're multiplying by 1/10. That's what happens as you move to the right. Multiplying by 1/10. And then that pattern continues. So how does each of these multipliers affect the placement of the decimal? So multiplying by 10 is moving the decimal one place to the right. You can see that as you go from right to left. So how does this multiplier, 1/10, affect the decimal? And we talked about that previously. You would be moving the decimal one spot to the left. So multiplying by 10 moves the decimal one place to the right, multiplying by 1/10 moves the decimal one place to the left. And I would maybe get that written in your notebook somewhere. Okay, 2 more questions we want to answer. If we were using the patterns that we found in the table to write, we want to use the patterns that we found in the table and now write 10 to the negative 7th as a fraction. So make sure you get this example in your notes as well. But if we look here, this 10 to the negative 1st, so that put 10 on the bottom. Just like 10 to the 1st is 10, 10 to the negative 1st is 1 over 10. We go to 10 squared, we would have 100 over 1, but 10 to the negative 2nd is 1 over 100. So it's almost like the reciprocal of its match. So a positive 2 compared to a negative 2 puts 100 over 1 or 1 over 100. 10 to the 3rd or 10 to the negative 3rd, 1,000 over 1 or 1 over 1,000. So if you think about what 10 to the 7th is, 10 to the 7th would be 1, whoops, that's not where the comma would go, with 7 zeros, so it's 10 million. So 10 to the negative 7th, I don't know why it keeps doing that, 10 to the negative 7th would be 1 over 10 million. It's a very small number. The next question we want to answer is, again, using the same patterns we found in the table. Now we want to write 10 to the negative 5th as a decimal. So this one's a little trickier, but not quite. So we're going to go from a counting zero kind of a standpoint. So if we go from counting zeros, if we look at 10 to the negative 1, it's just 0.1. 10 to the negative 2 is 0.01, so there's 1 0 there. 10 to the negative 3 has 2 zeros. So the number of zeros between the decimal and the 1 is 1 less than that negative exponent. So we're at negative 5, which means we would have 4 zeros between the decimal and the 1. So this would be 0.0001. Okay, 2 more questions. Question 5 says to write 1 over 100 million using a single exponent. So, because we're in the bottom, we're going to be using a negative, and similar to what we saw in the pattern, we're just counting the zeros. 3, 6, 7, 8. So this would be 10 to the negative 8th power. And now we want to write the rule. What does it mean when you have a negative exponent? How can we write 10 to the negative n as a fraction? So if we look at what is 10 or 100 million, 100 million is 10 to the 8th power. So this is like saying 1 over 10 to the 8th. So when we want to write something with a negative exponent, it's the same as saying 1 over 10 to that positive exponent. So this is rule number 4. Remember yesterday in class I wrote 3 rules on the board. This is rule number 4, dealing with negative exponents. Make sure you have that one in your notebook. So following exponent rules, we're going to match some descriptions here, and I'm going to go kind of fast through this, but remember that you're welcome to pause the video if I go too quickly. It might be helpful to have most of these examples in your notebook. There are 3 images. So if you want to pause it, copy down this table so that we can match. And then you can play the video to watch how we match. So we have 10 to the 2nd raised to the 3rd power. We have 10 to the 2nd raised to the negative 3rd power. We have 10 to the negative 2nd raised to the 3rd power. And we have 10 to the negative 2nd to the negative 3rd. So this first one, this is what we were working with before we dealt with any negatives. What does this mean? This means 10 squared 3 times. So where do we see 10 times 10 times 10 times 10 times 10 times 10? And that's down here. So those two match. Now we have 10 to the 2nd, but it's to the negative 3rd power. So this is like saying 1 over 10 times 10 times 1 over 10 times 10 times 1 over 10 times 10. So that would be this one right here next to it. wait, sorry. This one up here. Now we have 10 to the negative second to the third power. So 10 to the negative second is 1/100th. So where do we have 1/100th times 1/100th times 1/100th? Well, we have that here, and it doesn't really look like 1/100th, but remember that 1/10 times 1/10 is 1/100th. So then finally, this last one, it's like a fraction within a fraction. This is 1 over 100, and then 1 over that. So it's like 1 over 1/100th. And that's this one here. So now we're supposed to write 10 to the second to the negative third as a power of 10 with a single exponent. So what were our rules? When we have 10 to the m raised to the n, remember what we did there, we would just say 10 to the mn. We multiplied. So that rule doesn't change. This becomes 10 to the negative sixth power. I actually really like working with exponents because they're kind of like puzzles. So hopefully you're enjoying this too. So now we want to match again. Match expressions that describe repeated multiplication in the same way. So the first one is 10 squared over 10 to the fifth. That's 10 times 10 on top, and 10 times 10 5 times on the bottom. That's here. Number 2, we have 10 squared over 10 to the negative fifth. So remember, this is going to be 10 times 10 on top, and 1 over 10 5 times on the bottom. That's down here. 10 to the negative second over 10 to the fifth, that's 1/10 times 1/10 on top. Remember, that's putting that 10 on the bottom, the 1/100th. And then 10 times 10 5 times on the bottom. That's here. And this last one, we've got both negatives, but 10 to the negative second, 10 to the negative fifth. That's going to be fractions on top and fractions on bottom. That's going to be this one here. So write 10 to the negative second over 10 to the negative fifth as a single exponent. So what did our rules say before? If we have 10 to the m over 10 to the n, we subtract m minus n. That's not going to be any different here, but you have to be careful because we're working with negatives. And I'm going to show you the quick way and then how that works the long way. So if I have negative 2 and I subtract negative 5, okay, remember it's m minus n, so it's negative 2 minus negative 5. That becomes adding the opposite. Negative 2 plus 5 is negative 3, so we would get 10 to the negative third power. Now if I show you the longer method for that, I'm going to go ahead and use this right here because it's already drawn out for me, so I don't have to draw it out. So if I simplify this, up top I have 1 over 10 squared, or 1 over 100, and on the bottom I have 1 over 10 to the fifth. So you're going to see why this subtraction still works. Well, what does this become? Dividing by fractions is the same as multiplying by the reciprocal. Well, now what do I have? Now I have 10 to the fifth over 10 squared. And this is the rule we worked on the other day with division. This is 10 times 10 5 times on top, 10 times 10 twice on the bottom, 2 on the bottom. Wait, hang on a second. This is supposed to be a positive 3. Sorry about that. Negative 2 plus 5 is 3. This should be 10 to the third power. So 10 to the fifth over 10 squared, that's 10 to the third. So you can see it. This is probably the easier way to do it. If you want to write it all out like that every time to help, then you're welcome to do that. Okay. Matching this time with repeated multiplication. So this top one is 10 to the fourth, so 10 tenths times 10 to the third. That's down here. Now we have 10 to the fourth times 10 to the negative third. So that's 4 tenths and 3 1/10ths. 10 to the negative fourth, 10 to the third. That's 4 1/10ths and 3 tens. And then finally 4 1/10ths and 3 1/10ths here. So now we're looking at multiplication. Does our old rule still apply of adding exponents? So if we write 10 to the fourth times 10 to the third as a power of 10 with a single exponent, we're going to add negative 4 plus 3 is negative 1, so we get 10 to the negative first. And how does that work? Well, I'll show you. If we have, and I'm going to use, where is that? This one. So I'm right here using this one. If I multiply across here on these fractions, I get 1 over 10 to the fourth times 10 to the third. Well, that's 10 to the third over 10 to the fourth. Put this over 1, and I treat these like fractions. My rule was subtraction, right? 3 minus 4 is negative 1. This also is 1/10. So remember that means 10 to the first on the bottom, but because it's on the bottom, then we say negative 1. So what are we learning? Hang on. We're learning that all of our rules will still work even though we're dealing with negative exponents. So when you multiply powers of 10, you can still add exponents. When you're dividing powers of 10, you can still subtract exponents. And when you have a power raised to a power, you can still multiply exponents, even though we're dealing with negatives. So let's go through the lesson synthesis real quick. So the first question is, how would you write 2,796 as a sum with powers of 10? So this one's kind of confusing, but 2,000 comes from 2 times 1,000, 7 times 100, 9 times 10, and 6 times 1. So if I want to write with powers, it would be 2 times 10 to the third, plus 7 times 10 to the second, plus 9 times 10 to the first, and I'm running out of room, plus 6 times, or what's supposed to be times? 6 times 10 to the 0. So we talked about this. What about really small numbers? And that's really what the key here is that negative exponents are just really small numbers, right? 1 over a million is a super tiny number. And it's much more convenient to write it with an exponent than to write 1 over and then write out the number 1 million as a fraction. How would we do this one? The 0.2796 as a sum with powers of 10. Well, this would be similar to how we did the top, but it's just with negative exponents. So 2 times 10 to the negative first, plus 7 times 10 to the negative second, that's the hundredths, this is the tenths, plus 9 times 10 to the negative third, plus 6 times 10 to the negative fourth. And how are 10 to the third and 10 to the negative third related? Well, they are reciprocals of one another. So exponents tell us to multiply, so this would be multiplying 10 3 times. Negative exponents basically mean division, so we are dividing by 10 3 times or multiplying by a tenth 3 times. So what kind of people work with really big numbers or really small numbers? Typically in the sciences, so astronomers might be working with really big numbers. How far away are planets? How far away are stars? biologists, physicists, engineers, those all are all fields where you might work with really small numbers. We'll do the cool down when I come back, just to kind of help see how well you've understood the lesson. So you'll need to show the sub your notes, and then he or she will give you the worksheet that will be homework if you don't finish. Again, if you have any questions, you can send me an email.